In almost any food processing plant, you will encounter various types of liquids being pumped from one location to another in pipes. For example, if you go to a dairy, you will see milk or hot water or steam being transported from one location to another in a pipe. Uh, in a food dehydration plant, for example, a plant that is manufacturing spray dried milk, you will see pipes that are being used to convey heated air. So it is important that we gain an understanding of the characteristics and the flow behavior of different types of fluids. In this module, we will look at some introductory concepts, and then we will expand on those in some of the following modules. First, what do we mean by the term fluid? Well, fluids encompass both liquids and gases. Of course, you are also familiar with solids. So first, maybe we should look at how we can differentiate between a solid and a fluid. One way to gain an appreciation of this is by our simple observation that fluids flow, whereas solids don't. So if we apply a shear stress to a fluid, it will continuously deform. In other words, it will flow. So let's look at some of these terms. What do we mean by them? Stress is force per unit area. So when we say we are applying stress, what we mean is that on a given area we are applying some type of a force. And shear means that the force is being applied tangentially to that surface. So here is a little block, and imagine that we are applying force that is tangential to the top surface. So what happens if we apply this shear stress to a block of steel? Now imagine that we have this block of steel fixed to the ground, so it cannot move on this plane. However, if we apply a force on the top surface, we will deform the steel block. However, as soon as we remove the force, that top surface comes back. So that is the property of a solid, that when we apply this shear stress, although it deforms, it comes back to its original shape. On the other hand, imagine that instead of a steel block, we have this block made of some fluid. Now if you apply a shear stress on the top surface, the fluid will not come back to its original shape. It will continue to deform, or in other words, we say it is going to flow. So let's get back to our simple fluids like water or milk or juice and so on. When we study fluids, we tend not to study them at the molecular level. Instead, we consider a small volume of fluid, and then we try to understand its behavior. Although that small volume is made up of molecules, but again, in case of fluids, we always like to work with a small volume of that fluid. Another important characteristic of fluids that we will be considering is that the characteristics of fluids vary continuously throughout the fluid. So fluid is what is called a continuous media, and we will encounter terms like continuity or continuum. They all are referring to the fact that the characteristics of fluids vary continuously throughout the fluid. Now there are several types of forces that may act on a fluid, such as pressure, gravity, friction, and so on. Both the magnitude and the direction of the force are important when we consider the action of a force on a fluid. There are forces that contribute to the flow, and then there are other forces that are opposing that flow. So many times we try to determine what sort of forces are aiding the flow and what are actually retarding the flow. We also know from our general observation that if the pressure is higher on one location than the other, then the fluid moves from higher pressure to lower pressure. You also know that gravity plays a role. For example, in a waterfall, water is at a higher altitude at the top of the waterfall, and then of course it moves to a lower elevation. Thermal gradients also cause fluid flow. At higher temperatures, there is a decrease in the density of the fluid, so it rises, and a colder fluid then takes its place. And these are some of the general characteristics of fluids, along with the simple observations on flow behavior. We will now look at some of the specific properties of fluids that are important, and also try to get a better understanding in quantitative terms the flow behavior in under different circumstances. And those will be covered in the following modules.